Welcome back to my channel, everyone. It's Retips here. And I've allowed this to settle overnight, and as you can see, the solution is pretty clear. There's no sediment in there. And the first thing we want to do is get a stannous chloride test to see if we have any precious metals in solution. Let's get a little bit of the solution on a piece of filter paper here. And I do not see any indication of any precious metals other than silver chloride. Now we're going to draw a little bit of the solution up into this beaker, and I want to test to make sure that we do in fact have some silver in here. What we'll do is just take a little bit of hydrochloric acid now, add it to this solution. If there's silver chloride in here, we'll get a bloom of white silver chloride forming. And there you can see there's definitely silver chloride in here, quite a bit of it. Got my vacuum pump running. I've got a number 42 filter paper in the funnel. I'm going to wet this with a little bit of distilled water, get it to seal up. Now we got a vacuum drawing. I'm going to pour the solution through the filter now and filter it out. Our solution is kind of thick, syrupy, and so it took a while to pull through this filter. It's been filtering now for about 20 minutes. While I'm waiting for the rest of this solution to pull through this filter, what I'll do is I've got a jar here that I save all my silver test solutions in. It's full of silver chloride. And I just add these solutions in, and then when I get enough accumulated in here, it's about half full, I'll take it out and we'll convert it to pure silver with lye and sugar, and then make a pure silver bar out of it. I use a tight fitting lid, and I store this under the sink out of the light, because light will turn this. I like to keep it nice and white. This will keep the light off of it, store it in the dark. It doesn't hurt anything if the silver chloride does get exposed to light. It doesn't hurt a thing, but I like to keep it nice and white. As you can see, there were some solids, and sometimes there could be a little bit of precious metals in here, so it's worth it to filter the solution and get the solids. I'll save these, put them in my paper storage. Silver is a carrier of gold and platinum group metals. Got everything pulled through the filter now. What we'll do is take our funnel out, take our filter paper, add it to our paper storage up here. This is getting kind of full. We're going to have to make a video on how to recover the precious metals out of our filter papers here. We've got the solution filtered. What I would normally do is add the solution to my silver jar here that's full of silver, because there's going to be excess nitric acid in this solution, and I want to consume that before I attempt to cement out the silver with copper. But I'm not going to do that because that would throw our yield off. I just added the solution to this beaker, forgot to turn the camera on. What we're going to do now is add some pieces of copper here, and we're going to cement out the silver out of this solution with some pieces of copper. You can see here that the beaker is loading up with nitrogen dioxide fumes because we've got a whole bunch of excess nitric acid in this solution. What's happening is the silver is coming out of solution onto the copper, and then since there's a whole bunch of excess nitric in here, it's redissolving and creating these fumes. Also, the nitric acid is attacking the copper and needlessly consuming the copper that we have in here. That's why when we do this reaction, we want to make sure all of the excess nitric acid has been consumed, or most of it anyway. A little bit of excess nitric is required for this reaction to happen, but we want to get most of it out of there ahead of time so that we don't needlessly consume our copper. This is about 1 hour of footage condensed into 20 seconds. And here's a good example of why we want to make sure all the excess nitric has been removed before we add the copper to cement the silver out. You'll notice that the silver is bloating, rising to the top. We've got a lot of heat and a lot of fumes being produced. This reaction's been going now for about an hour and a half. You can see down here we're starting to get a little bit of silver building up down on the bottom of the beaker, which is what we want to see. So now what I'm going to do is I'm going to go ahead and stir this up a little bit. As the reaction progresses, we'll see less and less of these fumes and heat as the excess nitric in here starts to be consumed by the copper and the silver. I'm going to add a little bit of distilled water here, maybe about a liter or so. This should help calm things down in here. Stir this up and let it continue to react. This is about 3 hours into the reaction. We're still getting a little bit of fumes and a little bubbling. It's still kind of warm. Just going to stir it up good here. We'll come back. I can tell it's getting close to being completed because our copper is staying a pink color and no silver is forming on it, so we're pretty close to being done here. It's been about 6 hours since we started cementing the silver out. And if you look down in here, I think we've pretty much got it all out of solution now. Onto the copper. There's our pieces of copper. They're not turning gray anymore. So let's go ahead and get this cement silver out of this solution now. I'm going to begin by taking out these pieces of copper, and I'll just set them in a temporary container over here out of the way. It's gonna fight me. Look at that. I'm just gonna reach in there with my fingers and grab it. I'm gonna reach into our beaker here, get a little bit of our solution, put it in this smaller test beaker here. And now what we'll do is add some hydrochloric acid. See if we form any silver chloride in there. And I don't see any silver chloride forming in there. So it's safe to conclude that we've got our silver cemented out of this solution now. Alright, what we're going to do now is transfer this solution into my silver waste bucket here. It's full of copper down in the bottom, and I'm just going to pour this liquid off. Alright, here's our silver metal, cement silver. Here's the cement silver, It's got a blue precipitate that has formed in here. And so I noticed when I poured hydrochloric acid on the solution that came out of here, we got a reaction. Okay, before I go all in with the main batch, what I'm going to do is add a little bit of hydrochloric acid to this silver, which is highly unusual. We do not usually do this. What I'm attempting to do is dissolve the blue precipitate and leave just the silver here. And it looks like it worked out pretty good. But before I go all in and pour hydrochloric acid in here, I wanted to do a small test batch to make sure that we're going to be okay. Here's our cement silver. I think we're going to be okay. Well, here we go. We're going to rinse our cement silver with hydrochloric acid. That's not going to be a problem because we'll probably use this to run it through our electrolytic silver cell. Here we go, hydrochloric acid on cement silver to dissolve out that blue precipitate that's in there. Normally hydrochloric acid is something you want to keep away from silver, but in this case, to get that precipitate off of our cement silver, we'll need to utilize hydrochloric acid. This is all brand new to me, as usual. A brand new step I'm adding here. I'm going to hit it another dose of hydrochloric acid here. I'm going to pour this off now into the waste beaker. Not sure what's going on here chemistry wise, but it is doing a pretty good job of cleaning up my silver. There's going to be a little bit of silver that goes into the waste jar, but hydrochloric acid will not dissolve silver, so I'm not worried about that. Just going to rinse it a couple more times, see if I can get some of that color to go away. I allowed that to settle for a couple of minutes, and then we'll pour off the waste solution. A little bit of the silver is going to go into this waste container that I'm pouring the solution off into. That's okay. It's not going to be more than a couple grams, and I can recover it later on. Here's how the silver's looking. Try some distilled water rinse here to see what happens. Looks a little better. Now let's do a quick stannous test of our waste over here. See what's up with this. I don't see a whole big reaction there. I don't think we have any precious metals in solution. It's just going to be waste. Alright, let's pour the water off of here. The silver's starting to look pretty good now. Like I said, a little bit of the silver will probably get poured off into this smaller beaker here on my left, and I'll get that at a later time. Here's the test batch that we did a test on to see what the hydrochloric acid rinse was going to do. I'm going to add this back in now. I don't know what we got here exactly. I know there's silver in here, but that's more hydrochloric acid that I just added. And I just hope that this is not what I think it might be. Let that settle out and pour it off into a waste container. All right, let me pour off this hydrochloric acid rinse. Still got a little bit of a greenish tint to it. And I've heard tell of people getting tungsten in their silver. Tungsten is below copper in the reactivity series, so it will cement out along with the silver if it's present. Get this into a melt dish, melt it up. But I don't know exactly what we've got in here. Doesn't look too clean to me. I mean, there's obviously silver in here, but there's something else coming out of solution when I rinse with water. Here I'm going to put a little bit of the material in a small melt dish and do a test melt before we go all in and try to melt the entire batch. Now this is time lapse. It took about 5 minutes to do this melt, and you'll notice when I get done with the oxyacetylene, the little bead or button forms up nicely in the bottom of the melt dish. And here I'm going to sprinkle some borax on the little piece of silver there. And then we're going to pry it out of there with a pair of metal tweezers and throw it into a container of water. Here's our little button of silver. It don't look too bad. And what we'll do is just set it off to the side. And I went to pour the silver out of the beaker into the funnel there. Made an adjustment and forgot to turn the camera back on. But anyway, we got the silver into the filter. From here on out until the end of the melting sequences, I'll be narrating because I've got my respirator on. I don't know what kind of material is in here, and I don't want to be breathing those fumes. This took about 10 minutes to complete the melt, and that pretty blue color there is probably from copper oxide or some other compound of copper. When copper compounds burn, they produce a pretty blue flame. In these next sequences, you can see I've got some sort of bizarre molten liquid in with the silver. I have no idea what that liquid is. It's just another mystery to this recovery. Not quite sure what that liquid is. I tried to dump it in some water, and it was too violent of an explosion to do that, so I ended up dumping it on the concrete, and then I just pried the piece of silver out with that pair of tweezers there. In my entire 11-year experience, I've never seen an uglier piece of silver in my life. So what I did is I just got another melt dish, and I'm going to throw it into a clean melt dish and do a remelt. There was still some liquid present in with the silver on this second remelt, but it's starting to look a little better here, and there's a little less of that molten liquid. I don't know what that liquid is, and here I'm adding some borax, trying to get some of that contamination away from the piece of silver. It's looking a lot better than that first melt, and that was my goal, is to kind of clean it up by doing a remelt. It looks a lot better now. You can see here the piece of silver starting to look a lot better. If 2 melts makes it look that good, I figured a third melt, it'd clean it up real nice, so I put it in another clean melt dish and did a third melt. This is time lapse, and you can see the silver is starting to look like good pure silver that I'm normally used to looking at. And so I'm very pleased with this third remelt. Here I'm going to add some borax, try to get some of that trash that's might be floating on top of the silver away from it. And what ended up happening here is I left it in the dish a little bit too long, and it got glued in. I tried to pry it out of there, and it was glued in. I couldn't get it out. So the solution to that is to heat the piece back up with some more flame, and then once I got it heated up, I was able to pry it out of there with the tweezers. This looks much better. This is what I'm used to seeing when I melt cement silver. I'm going to add a little distilled water to this container. I'm going to put our silver button in here. And now we're going to add a little bit of sulfuric acid, hopefully get all that flux to come off of there. That took about 10 minutes in the dilute sulfuric acid here. And now what we'll do, if we can, is carry it over here to the sink and let's rinse it off. Let's see what it looks like now. Don't look too bad, I guess. Got a nice puck of silver here. Got some craters on the bottom, looks like the moon. Here's our piece of silver that we recovered from the silver-coated copper wire. It was not an easy recovery, and this is going to be silver, but I'm not sure what the purity will be. Looks like we got just over 3 troy ounces. It's 94 grams of silver that we recovered from that wire. All right, let's go ahead and stamp this up. I thought that this was going to be an easy recovery, and it turned out to be one of the most difficult silver recoveries that I've ever done. But I did get the silver and stamped it up with my name on there. And what we'll do is just let this go just like it is. It's probably about 99% pure silver. It's got a neat moonscape look to it on the back there. And I'll list this on my eBay store. We'll start the bids at 99 cents and let this 3-ounce puck of 99% pure silver go for sale on my eBay store. That'll conclude the video. Thanks for watching.